Okay, now pause and see if you can do r equals cosine theta. I suggest that you make a table for r as a function of theta. Pause and see if you can do that and see what kind of a shape you get. Okay. Now, when I made the table, I chose to let theta go by an increment of pi over 4. Okay. Now, it's not always clear just what kind of an increment you need for theta if you're doing this kind of a graph. We'll see another example in a minute that gives you a little bit of a hint, but what we want is we want the argument of the cosine function to change, but not too fast. And we could have, the argument of course is theta. We could have used 0, pi over 2, pi, and so forth, but it's a little more instructive here to use 0, pi over 4, pi over 2, and etc. If you don't get a really good picture with the interval or the increment of theta that you're using, then you probably need to use a smaller increment just to see what's going on. And it's often good just to start out with a small increment like 0, pi over 6, pi over 4, pi over 3, pi over 2, and see how much information that gives you. And if that gives you enough information, if it gives you more information than you really need, then you might go to a smaller increment. In any case, in class here I use an increment of pi over 4. So, these are the approximate values of r that we've obtained. Okay, and that's very simple. We just evaluate the cosine at these angles, and you should know that very well by now. Then we come over here and we plot the points. Okay, 0, 1. Theta is 0, and r is 1. That means an angle of 0 is along the polar axis. R equals 1, that's right here. That's the point 0, 1. Now these are rectangular, these are polar, not rectangular coordinates. And you know, I've done something really stupid here. And it appears on the home page also. I must have been tired this day or something, but I was doing my theta first and my r second. And that's, of course, completely wrong. All these need to be reversed. I'm going to let the error stand, just as a warning for you not to do the same thing. I was simply focused on the angle and wasn't really paying attention to the way I wrote these things down. But these are all backwards, and that's something you certainly don't want to do. Okay, so this really should read 1, 0, not 0, 1. And at angle 5, or pi over 4, we get 0.71. The point is clearly right here. Okay, the locations of the points are not going to change. It's just that I've done everything in reverse order. So this ought to be 0.71 pi over 4. And this ought to be 0 pi over 2. And so forth around this figure. Now how do we get the figure? Once we have the points for theta equals 0, pi over 4, pi over 2, 3 pi over 4, and pi, we see that as our angle changes from 0 to pi over 4, we're going to have to go from here to here. So we think of moving around this way and meeting these points. And when we do, this is what we get. Now, this isn't the accurate form of the figure. Actually, this thing makes a perfect circle, but we don't know that. And when I sketched this, I sketched it about the way a lot of people might well sketch it the first time. Something kind of close to a circle, but not perfect, because until you do a little proof, you're not sure that it really is a circle. And we're going to do that. We're going to prove that in a minute. See exactly why it's a circle. That's one thing you want to note. Another thing is, we've just gone from theta equals 0 to theta equals pi. We've still got all these angles up to 2 pi, so let's see what happens. Okay? Well, if we go to 5 pi over 4, which would be an angle down here, a direction down here, we get negative 0.71 for the displacement. Now, if we go in this direction in a negative displacement, that means we're going to come back and we're going to meet this point. So we see our 5 pi over 4 is associated with negative 0.71. And our 3 pi over 2 is 0. That's going to be the pole, so that's not going to affect anything. But 7 pi over 4 is now 0.71. Where's 7 pi over 4? Well, that's down here in the 4th quadrant. Okay? Just like the 3 pi over 4, negative 0.71. Okay? We went 3 pi over 4. We went at displacement negative 0.71 for this point. Now we're going to go 7 pi over 4 with a positive 0.71, and we're going to end up at the same point. And then, of course, when we get to 2 pi, we're going to be at 1, and 2 pi is, of course, in this direction. Just like when we came around to pi, we had negative 1. Okay, pi, negative 1, pi was out in this direction, but negative 1 brought us back this way. So you see, we've just repeated the same points. And, of course, that's going to happen for all the points between the angles that we've listed here. And we're going to just repeat the same curve. As we said, this curve is a circle. Okay, we say it's something like this. It's actually a circle, and we're going to see why that's so in a minute.